With distributed execution in MapReduce, each stage that we perform passes through the hard drives. So the initial step of the map reads data from the hard drive, processes it, and then writes it out to disk before we perform the shuffle operation to send data to the reducers. At the reducers, they read the data in from disk, process it, and write the results out to disk. As a result, if we have an iterative job, so here a job that has 3 stages and we're just repeating that, so we do stage 1, stage 2, stage 3, then repeat stage 1 again, then there will be a lot of disk I/O operations for each repetition. You can see this in the figure above the stage 1, stage 2, stage 3 diagram. Each of those mappers is reading in data from disk, then writing data to disk, only to be read back again from disk by the reducers, written to disk by that reducer, then read again by the next stage's mapper, and so on. The problem here is that disk I/O is very slow. So if we're running iterative jobs, they're primarily going to run at the speed of the disks instead of the speed of our CPUs. This is a motivation for Apache Spark because it's not just iterative jobs that we want to perform when we're doing data science, but also complex jobs like interactive mining or stream processing or interactive queries. In each one of these cases, we start with some source data and we repeatedly read that data and perform calculations and write data back out to disk. That high amount of disk I/O means things are going to run very slowly because, again, disk I/O is very slow.